Hello, Science Alliance! Hello, I am Lara. This is Theory of Science. We are learning about the polar regions. This is lesson 2, but you don't have to have seen lesson 1. Last week, we sort of stepped back and looked at actually why there is ice at the North Pole. Sort of top. There is no top and bottom, is there? Space doesn't care about which way up a planet is, but we'll say at the top, the North Pole, and the South Pole, we looked at why they're so cold. And this week, I thought we'd just look at all about ice. And then the next 2 weeks, we'll look at animals of the Arctic and the Antarctic. And then we're going to look at the Northern Lights and the Aurora. And then that's it. It's quite a short module, this one. So let's get started. Let's think about ice. The first thing we need to do is set up this activity. Some of you have done this before. We did it fairly recently when we did our climate change lesson, but we've got to do it 'cause it's about ice. So what you have to do is get a glass, any glass, get some ice cubes and put water in the glass. What you need is for the glass to be as full of water as it possibly can be without overflowing the sides, and you need some ice cubes to be sticking out the top. It's actually quite difficult to do, but I'm going to do it now in front of you live. Brilliant. Here we go. Right, so you come down here with me. I haven't really worked out the best way of doing it. I'm putting a few ice cubes in and then filling it with water and then putting a few more ice cubes in. Yeah, I think that is what you have to do. Oh, please can you save one ice cube? Just take your nicest looking ice cube if you've got a few and put it to one side because we'll study that in a second, okay? Right, so put that over there. Yeah, I think the best way to do it doesn't matter if, obviously, if you're not doing it, you can just look at mine. A few ice cubes in and then fill it nearly full with water, but not quite. And then you've just got to try and put more ice cubes in so that some of them stick out at the top. Oh, man, come on. Maybe I need to put a drop more water in. I don't know. Oh, come on. I've only got so many ice cubes. Yeah, it's not very good, is it? They're not really sticking out. Okay, I've got more. Oh, that's still quite lame. But it hasn't overflowed yet. I'm going to go for one more. Oh, it's not too bad. I feel like I could have more sticky uppiness. But I also think that might be as full as it could get. Is that as full as it could get? I'm going to try one more cube. I'm going to try one more. I know. It's because this is the last time I'm going to do this lesson. I can use up all my cubes. Come on, just a small one. It doesn't really matter if it overflows. The reason I don't want it to overflow is because I'm going to ask you in a minute if you think when the ice cubes melt, is the water going to overflow or not? Oh yes, look at that. And I just think it'll be easy for you to tell if the water's overflowed if at the moment the bowl underneath is completely dry. Yeah, so that's the only reason I don't want it to overflow. Okay, yeah, I think I'll leave it at that. As you can see, thanks to water surface tension, we've got it. The water's actually even a little bit higher, I think, than the edge of the glass. So, but I've got some ice cubes sticking up, so I'm going to leave it there. Okay, yes, my question to you is, what will happen when the ice melts? Some of you, if you came a couple of modules ago, we did all about weather and climate. So some of you know this. I've put, if you know, don't tell the others, but try and sketch the particles to show why. Because it's really easy to think, oh yeah, we've done this, I know. Yeah, but actually why? Can you tell me why? Because we didn't really go into that much detail about why. And we will this time, because it's ice. The whole lesson is about ice. You can hear me really subtly blowing my nose. Oh, less subtle, but more satisfying. Okay. So, is the water going to overflow when the ice cubes melt? Is the water level going to go down, right? So it looks like there's less water in the glass. Or will the water level just stay exactly the same? Just quickly answer that and then we can move on. So we'll just slowly let the ice melt throughout the course of the lesson and then we'll come back to it at the end. If you've been to my Facebook group or my website, you will have this on a worksheet. If you haven't, don't worry about it. You can just think it with your brain. Okay, right, let's get started. Well, I thought the first thing we should do is look at what is water. Because, I mean, actually, when you say ice, you could mean any kind of substance that is frozen. Like when we talk about other planets, you know, on Mars, there's carbon dioxide ice. So, but let's talk about what water is, because that's the kind of ice that we're talking about here on planet Earth. Here's a water particle. You've probably heard water called H2O. Water particle is just two hydrogen atoms bonded, that's what these lines are, to an oxygen atom. So that's a water particle. Is this a water particle? Two oxygen atoms just kind of floating around near an oxygen atom. Nope, it is not. So when I say water particle, I mean 2 hydrogens bonded to 1 oxygen, okay? Water particle. So, liquid water, these water particles, just very sort of randomly arranged. They are touching each other, but they're not very organised. I always say the particles in a liquid, they're kind of like a ball pool, right? So they're close together, the bonds are actually constantly forming and then breaking again. So they can touch each other, but they're moving around as well. Solid water, someone asked last lesson, well, actually, someone told me that water was a mineral, and I didn't know. But yeah, I looked it up. Of course it is. Yeah, ice, solid water, is a crystal. And it looks like this. Isn't that beautiful? I've put so organised. So you've got water particles, but you can see, right, they're quite far apart, and they've got these dotted lines in between them. Those are bonds bonding the water particles together. So water is actually really unusual. Really unusual in that the particles, when they're a liquid, they're really close together. But as they get colder, the particles actually spread out. That doesn't really happen for any other stuff, so not that I can think of. Yeah, they cool down, and as the water cools down, the particles lose energy, and so they're slow enough for these special bonds, they're called hydrogen bonds, to form, which makes the water spread out. And yeah, it is, it's a mineral. It's got a sort of crystal, beautiful, regular arrangement of its particles. So, quick recap on what we did last week, in case you weren't here. We learned Antarctica, the South Pole, where the penguins are, that is land, this white stuff, surrounded by water. And the Arctic, the North Pole, is sea. You can see here it's just blue at the top. It's sea surrounded by land. It's a bit confusing because on globes they don't usually show you ice. So on my lovely posh globe here, the North Pole, it's a bit scabby now, it just looks like water, whereas actually there is ice there. It's just on a globe you don't show ice. But whereas Antarctica, obviously that is there because that is ice that is on top of land. Okay. So I thought the first thing we'll do is talk about sea ice. If you've got one ice cube, can you get it out? Let's look at an ice cube and think about why that is kind of related to sea ice. Study your ice cube. What do you observe? I'd never done this before. Again, I was reading the Exploratorium website. They're ever so good. They give really good scientific explanations. If you haven't got an ice cube in front of you, you can study mine. So that my ice cube tray is like upside down triangles. So really, I should have the pointy bit at the bottom. What do you notice? I'd never thought about this before. Top view. Side view. Oh, shall I get I didn't do this on Facebook. Shall I get my hand lens out? Yeah. Wormy is guarding my hand lens, which we haven't used for ages. I love an opportunity to use my hand lens. I think it's actually for sewing, but I just look at everything through it. Here we go. Oh, look. So we can see some. You see some sort of bubbles now at the top? So have you noticed that it's very clear at the top? And then it gets cloudier towards the bottom. Do yours do that as well? Oh, and there's loads of bubbles, look. What are those bubbles of? And they're kind of, you see, they're sort of not randomly arranged bubbles. They're almost like in lines. Okay, sorry, this is not great, Telly. Okay, well. Your ice cube is sort of not a bad model for how sea ice works. So what's happened, the reason that your ice cube, you might have noticed, it's very clear at the top and then it gets cloudy, that's because the top bit was the bit, certainly on mine, that was exposed to the freezer. So those particles have frozen first. So those water particles have slowed down first, formed ice, and it's pushed all the impurities that are in the water down and down and down. But eventually they've got no choice but to freeze. So that's why the top bit is this lovely kind of very clear, very pure crystal, I suppose. And then as you get further down, it gets cloudy because, yeah, that's where all, I don't know, like little bits of air and dust, whatever else was in my ice cube tray go. And also, yeah, you'll see lots of bubbles, and that's where air that was in the water when the top has frozen has been kind of forced down. So this is not dissimilar to what happens in sea ice. Here's a picture. In sea ice situations, tiny little crystals called fragile form, one of my new favourite words, and they bond together to make new, very thin ice, and then eventually water particles underneath that are in the ocean cling to the bottom of this layer of ice, and it eventually accumulates more and more water. So new ice, you call it, is less than 10 centimetres thick. And then as it grows, you call it young ice, which is between 10 to 30 centimetres thick. So yeah, that new ice, when it forms, it sort of squishes out the salt in the water. Salt has no place in ice crystals. You've seen how beautifully organised they are. So salt in the seawater gets pushed out. But it's a little bit more complicated than that, because young ice does contain pockets of salty water. I didn't know this, but in older ice, the salt water is being squeezed out, right? So ice, when it's just formed, you've basically just got these little pockets of seawater, and then as older ice grows and grows and grows, that salt water gets squeezed out. So old, they call it multi-year ice, can be 4 metres thick, 4 metres. And the salt water has been pretty much squeezed out. So I'd never thought about how people on polar adventures get their water, but apparently you've got to look out for the multi-year ice, because that's good for melting to drink. You don't want to be melting down new ice to drink it, because you'll just end up with loads of salt water in your mouth. Whereas multi-year ice that's, you know, it's been summer and winter and the ice has survived, that hasn't got as much salt water in it. So yeah, good for drinking. I know. Right. First this question. Why are there no buildings at the North Pole? Why are there no buildings at the North Pole? And why is there no flag on the surface of the North Pole? Good questions, eh? So there is a flag on the surface of the South Pole. Why is there no flag on the surface of the North Pole? Why are there no buildings there? In as much detail as you can, please. Why no buildings at the North Pole? Some of you might just be saying, like, because it's ice. Yeah, but why would that matter? If it's like 4 metres thick? No, you're right, no. It's basically because it's ice. I didn't know this. A group of Russians, I guess Russia's a very cold country, so they're very good scientifically dealing with like cold climates. A group of Russians did build a little sort of science house, a building for scientific study at the North Pole in 1937, and they stayed there for 9 months. And when the Russian ship came to pick them up, they had drifted on the ice 1,770 miles or something, absolutely miles away. So this is why there's no flag at the North Pole saying this is the North Pole, because it wouldn't mean anything, because very quickly it would just kind of drift somewhere else. Obviously it's really big sheets of ice, but it's still moving around. Not very practical building buildings on ice. Here's a picture of them. There you go. You can probably find more less royalty-free images online, but yeah, good story, huh? Okay, how hard were you listening there? A little recap of sea ice. This is horribly worded, but I'm going to leave it open. Sea ice is frozen seawater, right? It's just seawater that has frozen on the top. It starts as tiny little crystals, frazzle, which float on the ocean and bond together. So I've put older sea ice is something and contains less something. I should have said than young ice at the end, because it could be like older ice is something and contains less something than cats. But I quite liked that I was getting loads of different words on Facebook yesterday. Older sea ice is something and contains less something. Can you just complete that sentence so that it makes sense? There's no flag or permanent buildings at the something pole because it's sea ice, which moves around too much. Have a go at those. If you're feeling fancy, you could find as many words as you can to put in that first box and still make the sentence make sense. So people on Facebook yesterday were saying older sea ice is water. That's not really what I was going for. But it's not wrong, is it? Oh, thank you to everyone who's liked this. I should say, if you're new, there is a post on my Facebook page always when I'm live on YouTube that you can comment on if you want to, and I'll read them out at the end. Okay, I was getting at older sea ice is thicker and contains less salt. But yeah, you could have said older sea ice is multi-year, someone said yesterday, remembering that fantastic word because it survived for multiple years. That was good. And there's no flag or permanent buildings at the North Pole because it's sea ice which moves around too much. All right, let's look at some different kinds of ice then. So that's sea ice, ice that forms in the sea, melts in the sea, does everything in the sea. Let's look at land ice, otherwise known as glaciers. Get your cans ready if you haven't already. So some of you will not have done this, I'm totally fine. But I did say if you wanted to, if you heard me in advance, you could get a can of water. I'll flip you around. I said if you get a food can of water and you put about 4 tablespoons of salt in it and water and stir it and then put it in the freezer, then you should bring it to this lesson. Otherwise you can watch mine, you can do it afterwards. Yeah, so what happens is salt gets in the way of these water particles, okay? Water particles, we've said that when they get cooler, they slow down and they form these lovely hydrogen bonds and it makes ice. If there's salt in the way, they can't form those bonds as easily, so you've got to cool them down even more before they freeze. So that's why salt particles mean water has to be colder before it freezes. So I've got this can of ice here, and which is colder than kind of regular water ice would be. And water particles are in the air all around us, and they're obviously, we breathe out water particles. So they are doing something called A on the sides of the can right now. And I thought that was vaguely related to what we're doing, and also it's just really fun activity. So if you have a can in front of you, you could blow on it and see water particles doing even more of this A word, which is important when you talk about glaciers. What are they doing? They're A-ing on the side. I'm going to leave that there so more water particles can A on the side of it. And let's talk about glaciers. Glaciers form on land. Snow falls. You ready for these amazing special effects? Boosh, boosh. Snow falling on land. Boosh. And it builds up and up and up. It accumulates and gets squashed into sheets of ice, and then it slowly flows towards the sea. So it's fairly well known that Antarctica, near the South Pole, is a desert. It is a desert. It doesn't snow very often at all at Antarctica. But because Antarctica is also really cold, any snow that does fall, it just stays there. It's such a weird idea. Like the snow falls, it just doesn't melt, it stays. So it stays and it stays and it stays, and Antarctica's been there for, thousands and thousands of times, very long time. So eventually this snow is built up and got squished. And it forms ice at the bottom. The pressure from above sort of forms, ice. I didn't know this, but the ice in Antarctica, or in ice sheets, are like the biggest ice crystals that you can get. And then you can see, it is basically a river, so the weight of all that ice means that it starts slowly shifting downwards. It does, it looks just like a river. Obviously a very, very slow river, you can't really see it moving with your eyes, but yeah, river of ice. It's beautiful. Other words that you might have heard of, an ice sheet is a glacier that is very, very big, basically over 19,000 square miles. There's actually only 2 ice sheets on planet Earth at the moment. One of them is on the biggest island on the planet, Greenland, so near the North Pole, and the other one is on Antarctica, which is down there, as we've established. The other word you might have heard of is the ice caps. You heard of the polar ice caps melting. This is a bad thing. So they sort of sit high up, they're kind of dome-shaped, and they're smaller. New favourite word. This is the favourite word that I've learned, I think probably this year so far. This is firn. F-I-R-N. How good is that for Scrabble? What do you reckon firn is? It has to do with what I just said about how glaciers form. And you're looking at a picture here of something, it looks like jelly, but it's not jelly. It is made of water. What do you reckon firn is? F-I-R-N. So good. You'd have that in Scrabble, you'd be like, oh, I wish I had an E. Oh, I wish I had an M. No, worry no longer, friends. It is a word. You had a guess? Firn, F-I-R-N, it's that layer in the middle. So when a glacier forms, that ice is right at the bottom, being very squashed. Snow is at the top, and in the middle you get this layer that isn't quite ice and isn't quite snow. It's called firn. I know, right? Okay, so very quickly, the other bits of ice that you can get. You might have heard of ice shelves. God, it's just stunning. It's a massive cliff of ice. This is where glaciers meet the ocean. When the river gets to the ocean, you get this big shelf, and when a bit of ice shelf carves off, like breaks off, you get... This is why we're doing a story show about the Titanic next on YouTube. You get icebergs. So icebergs, they're in the sea, but they're different to sea ice. An iceberg is freshwater ice that has broken off from a glacier and is now in the sea, but used to be on land. Oh, that was a lot, wasn't it? Okay, I've got something for you to do now. Could you please tick these boxes to say what you think will happen to the level of the sea when land ice melts, sea ice melts, and icebergs melt? Again, you can just do it with your eyes if you haven't got the sheet. Sea ice that we've just talked about, first of all, ice that is just made of seawater that freezes and then maybe unfreezes. When sea ice melts, what do you reckon? Is the sea level going to rise? Is it going to go down? Or is it going to stay the same? Land ice, so glaciers, if they melt, is that going to make the sea go up, the sea go down, or stay the same? And icebergs, ice that is already in the ocean, but it's from the land. When they melt, is ice going to go, sea level going to go up or down, or stay pretty much the same? Sorry. While you do that, I'm going to do a little bit more breathing on the side of my can. How have you got on? Have you had a guess? I hope it's a guess. Some of you will know, but it's more fun for me if it's a guess, because then I can do a big reveal at the end. Sorted? Okay. Just a couple more things then, and then we'll go back to our activity and we'll work it out. This is an overcomplicated diagram, but I thought it was nice. It's royalty free, just to give you an idea of how this behaves. So you've got a glacier here, and then some little fish showing you that it's the ocean, and then this big rectangular ice shelf sticking out over the ocean. So this is, it says glacier flow driven by gravity. So gravity kind of pulls all the ice down, and then you can see, especially if the water is warm, you get these cracks appearing in the ice shelf, and that's how icebergs carve off. And then finally our glacier is becoming quite unstable, and we've got lots of icebergs floating in the ocean. So glaciers can grow or they can shrink. So what happens is you've got this accumulation, that's the proper word, accumulation of snow at the top, and then it goes towards the ocean and then it breaks off. So if those things are both happening sort of more or less the same amount, then it's in equilibrium. If there's more accumulation, then there is bits breaking off, then that would be a glacier growing. And if there's more bits breaking off than there is accumulation, then the glacier is shrinking. That is generally what is happening around the world at the moment. The planet is warming up, so the oceans are warming up. So the warm ocean is carving off more and more bits from the ice. I'm so snotty. More and more bits from the ice shelf. Which is more than the snow that is accumulating. So that's why we say that the glaciers at the moment are retreating. All right, how carefully were you listening? Can you just label these levels for me? I just wanted to show you this picture. Look at this guy. This guy is 100% pure geologist, isn't he? Look at that, brilliant. We've got this chap who's on a glacier somewhere. He's dug a big hole. So you can see these, I think, more or less 3 different layers. I'm not a geologist, I don't know for sure, but it looks to me like there's 3 layers there. He's got his little neckerchief on to protect him from the sun, and he's boring into this glacier to take samples. What are the names of those 3 different layers, please? You've got a fluffy white layer right at the top, just above his head. You've got a very dark, sort of smooth looking layer at the bottom, and then you've got a layer in the middle. Have you done it? You remembered your Scrabble word? Oh no! Oh, that was such a mistake. I just did I just picked up my can to try and look at the frost on it through the hand lens and tipped it to the side, and it's not 100% ice. There's quite a lot of very cold water in there. That was very silly. Have you got it? So the top layer is snow. I'm so cold. The bottom layer is ice, and the middle layer is firn. Yeah, that's right. Whoa, lovely. What great job. Okay. And here, just as a little taster for a couple of weeks' time, is a map of the Antarctic ice shelves. So you'll notice that there's quite a lot of islands in Antarctica, these white bits of land that you can't see because it's ice shelf. So probably the most famous ice shelf in Antarctica is the Ross ice shelf down here. Here it is. But in 2 lessons' time, we're going to look at animals of Antarctica. Antarctica is massive! So I thought rather than just go, oh, what animals live in Antarctica, we'll actually look at which animals live where. We'll draw a little map. But yeah, that's next week. So let's have a little look at our activity and see what happens and then relate it back to this. Not all my ice cubes have melted, but hopefully you get the idea. You can see there's far fewer cubes sticking out the top than there were before. And, gasp! Can you see it's completely dry? Not a single drop of water has flowed over the side and into my bowl. Isn't that amazing? Some of you knew that would happen, and hopefully you've managed to kind of explain why. The reason is, well, I've sort of said it, haven't I? Shall I draw a little diagram? It's just a beautiful, amazing thing that ice does. If you picture a glass of water with an ice cube in it, some sticking out and some not sticking out. We've said that the water particles in ice are further apart than they are in the water. So the particles in this water, liquid water, are really close together. The particles in ice are further apart. It just so happens that when the ice melts, all the water particles that are in this bit sticking out the top, they just fit perfectly into this bit at the bottom. Physics, innit? That's so lovely. So, sea ice, when it melts, will actually not make it's not good for polar bears. We'll talk about that next week. But it actually doesn't make any difference to the level of the sea. Land ice, that definitely will make the sea rise. So that's like, well, I've got an ice cube left, I could do it. Land ice melting is just like this being the sea and more ice getting added to it, which, as you can see, there you go, will make it overflow. Sea ice melting, that's not going to make much difference. And icebergs, when the iceberg breaks off and plops into the sea, that's like what just happened. The level would go up. But an iceberg melting, again, it's just like an ice cube melting in a glass of water won't actually make that much difference. So yeah, it's good, isn't it? Some of you have seen that very, very recently, but well done if you remembered actually why that happens. Right, that is the end of the lesson. I know. There's no quiz where the answer is bums today, but I probably will try and work out one of those for next week because I enjoyed that last week. So I'm going to go over to my Facebook page and say hello to any of you who have left any comments on my Facebook page. It's just it's always the top post, not a pinned one, but just the kind of the last thing that I posted. Says, I'm live on YouTube. You can go and say hello if you want to. I better do my ad because some of you are new and might be thinking, what is this? Like, how is she doing? What is her job? This is my job. It's so weird. It's so cool. In lockdown, I just started streaming lessons for free for the Facebook likes. To be honest, it wasn't generous. It was just because I wanted more Facebook likes because I had like 100. But anyway, I sort of was thinking that it would just stop when lockdown finished. But then you wanted me to carry on. So I just put up a coffee page saying, if you want to, if you feel like you're using me as a resource, you can send me £5 a month. And then enough people did that this is a job. So good. So everything that I do is free. I stream this lesson for free every week during term time. An IGCSE physics lesson is just free. You should come to it. There's printouts for both of those that are free. They're on my website. For the IGCSE lesson, there's even a PDF of like homeworks and further reading. And I do a Lego Storytime show. There aren't any printouts for that. It's just ridiculous. Just a chat and an activity. That's my dishwasher. That's not me. That disgusting noise wasn't me. Still not me. Wow. Come on. I just got one chance to do my ads. This is how I make my money. I don't know if you can hear that. It's been really gross. So support me. Go to my About section, click the link to this website called Coffee, and you can sign up for £5 a month. So hopefully £5 a month isn't very much. It's the best value lesson that I've seen online. Not very much for you given everything that I'm offering, but it's quite enough from all of you that it's a job for me. And I will even send you nice things. I'm not going to show you the nice thing, but I send you Theatre of Science magazine. It's very good, and I send you some rainbow glasses and some stickers. And thank you very much to everyone who. Thank you so much to everyone who has subscribed, but also massive thanks to everyone who's been supporting me for 3 years and has to sit through that advert like every single day that they watch a lesson. It's really appreciated. I see you. Thank you. Oh, brilliant. Gemma and Kenton. Hello. Oh, you enjoyed Ice Week. Thank you. Me too. Yeah, I learned a lot this week. Hello, Michaela and Tegan. Hello. This is Kenton. It's his second. Kenton, member of the Science Alliance. Welcome. All right, Sophie and Ruben and Asa. Is it Asa? Asa. I should know this. Asa. I'm going with Asa. Hello. And Ruben and Sophie. Hello to you too. Clea will be there. And we printed the sheets. Yay, that's good. How's my new website? Sorting out, doing for you. Hello, Edmund. Oh, you've got lots of ice. Oh, that's good. And you've got snow in the garden. Oh, so jealous. Edmund says that bismuth particles. Edmund, this is the level of knowledge that I expect from the Science Alliance. That's what they call them. If you're watching me, you are in the Science Alliance now. Bismuth particles. That is a brilliant... Bismuth, isn't that like what they make tarmac with? Wait, Edmund, I need to look this up. Bismuth crystal. Wow, cool. It's a brittle metal. Anyway, I've got a bit distracted, Edmund. Okay, this is actually quite a lot of reading. Main uses. Used in cosmetics. Oh, right, no, it's not the stuff. Used to treat diarrhea. Look, we did get to bums at the end of the lesson after all. Used to treat diarrhea. Wow. Okay, brilliant. Well, I've learned something. So bismuth, a metal which is used to treat diarrhea, also gets bigger when it freezes as a solid. Cool. Thanks, Edmund. Not used to make tarmac. I don't know what I'm thinking of. Oh, Mum wants to know where the geologist is. I don't know. I can't remember. I think Antarctica, but I don't know. Oh, hello, Amelia and Kitty. Excited as always. It's even your mum's birthday today. Nice. Happy birthday. What a great way to spend it. Unless you're not here. Unless you're in a corner like eating Bakewell tarts, which would be good. I hope you're doing that. Goat's beat and pan au chocolat. Bella's here. Bella's here with the pan au chocolat. Splendid. Hello, Jay and Daisy and Daniel. Hello. Hello, Sky and Evie. All right, Mimi and Jimmy and Timmy, they're all eating the ice cubes. What is it with you like eating ice cubes? Oh, Grace and Hope. Oh, Grace and Hope here. Brilliant. Hello. Waiting and particularly excited. Oh, yeah, saw your... Have you got hail? Oh, yeah. Oh, Grace and Hope. You've got Grauple. That's what you've got. It sounds like a disease. It's not. So Grace and Hope are saying in North Devon, they've got... It's just not... They've got a peculiar form on the ground, not see-through like normal hail, and not tiny like snow. Very white, round, crunchy. Yeah, it's Grauple. We did about this in our weather lesson, like 2 modules ago. Yeah, I can't, because it was 2 modules ago and I'm 41, I can't remember. I might be 42, I can't remember how old I am. But anyway, Grauple is formed slightly differently to hail, and it's kind of squidgy. You have to watch the lesson. I can't remember. This is my dark secret that as soon as I've taught the last lesson on something, I just forget it all completely. Hello, Laurie and Flynn. Hello. Oh, Edward and Annabelle and Evelyn. Hello, Evelyn. And Rose as well. Annabelle wants you to know she's watching with her puppy. Oh, and cats Buzz and Socks. Wait, the puppy's called Luna and one of the cats is called Buzz. Nice. And Socks as well. Socks are... I don't know if Socks has anything to do with space. Hello, Arthur and Abba. All right, Tor, hello. Hey, Robin and Hissy. No way, Hissy's just out in the Manchester snow. I love it. Hello, all right, Hissy. Isn't it true that boiled water is not cloudy? Nice. There's a really good activity you can do, which I've never done. It's just really difficult and it's probably a bit expensive to source it. But if you get distilled water, which is pure water, not mineral water, which obviously has minerals in it, but if you can get water which is just water particles, it's really hard to get. You can boil water and sort of catch it. There's ways online of making distilled water, or you can buy it. So Bella's saying, is it true that boiled water isn't cloudy if it's frozen? I don't know about that. Because if you boil water and then you freeze it, if you boil water and then you just freeze the water that was boiled, you'd still have the impurities in it. If you boil water and you catch the water particles and then you freeze those, I assume that would be completely clear because there won't be any impurities in it. But again, I'm just riffing, right? This is the chat, I don't know, you'll have to go and look it up. All right, Myron Rose, hello. Imogen Ophelia, Science Day. Ah, Bella, your dad's planting trees. Your dad's priorities are all over the shop. Planting trees. Really? It's just like, get your message clear, eh, Bella's dad? Last week, he was playing with chainsaws. Now he's planting trees. You know a quicker way to do that? Just don't play with the chains, just leave the trees. Bella's dad. Bella's dad is the enemy of the Science Alliance. Oh, look at this, chickens in the snow. Oh, I've got to show them this. Look at this is so cute, but also maybe not good, I don't know. Can chickens survive in snow? I mean, obviously they can. These guys look fine, they're dead happy. Look at that view. Chickens in the snow. If I ever quit my job and instead form a band, I'm going to call my first album Chickens in the Snow. Chickens is actually quite a good name for a band. Okay, anyway, right, sorry, this banter is getting lower and lower quality. Let's scroll down. Tours there, excellent. Who else have I got? Chickens in the snow. I think the water will overflow as ice is much denser than water. Thank you. That would be true of nearly every other substance, apart from we've just learned bismuth and water. Yes, you're quite right. If it was like iron particles, they would be closer together when they were solid, and when you melted them, they would get further apart. All right, Alfie. No ice or snow here. Stupid Gosport. I love Gosport. Has a microclimate. Does it really? Get you guys. So it very rarely snows. It can be snowing in the next town and you would just get sleet. Really? All right, Suki and Aza and Musa and Salah and Eunice. Hello. Oh, yeah, here's the Grapple. That is definitely Grapple. Yeah, brilliant. Oh, thank you for showing me a Grapple. I love Grapple. It's my favourite weather. Just in case anyone ever wanted to know that. Okay, I'm just going to refresh because... oh, here we go. Yeah, okay, yes, this is the good activity. Thank you, I didn't get to this, Luna. If you get your distilled water, which is pure water, and you put it in the freezer, it doesn't freeze in the freezer, but if you shake it or you pour it out, then it will freeze. Yeah, it's amazing. I've never done it because I just think it's just very difficult for us all to get hold of distilled water, but maybe I should do it and show you. We have a thick snowstorm in Inverness. Oh, yeah. All right, Daniel and Miriam coming in from Inverness to... Like, oh, Devon, you got some little dots on the ground, have you? Well done, Devon. In Inverness, they've got a snowstorm. That's very cool. I'm quite jealous. That also does sound quite inconvenient. Maybe it's not cool to you after a while of living in Inverness. Oh, thanks, Danielle. That was nice. Oh, James caught alive for the first time in ages. One benefit of strikes is John is still in his bedroom. John, I'm glad that those strikes are working out. The strikes seem to be working out very well for you. That's great. James, hello. Good to see you. Tell John that I said hello. Excellent. That is why I refreshed the comments. Okay, I'm going to go because, oh, brilliant. The Lego Story Show on the Titanic is in 50 minutes, which is enough time for me to rejig the Lego Story Show and make it better. Obviously, everything I do is always perfection, but it's actually a bit long and not very interesting yesterday. So if you come at 10:30 to watch the Titanic Lego Story Show, it will be slightly better today. Don't tell anyone who came yesterday. Thank you so much for your support, you lot. I will see you very soon. Yeah, bye.